Hi, Assalamualaikum and good morning everyone. First of all, we would like to thank our lecturer, Professor Madya TS Dr. Muhammad Zahid bin Hassan for giving us this opportunity to present our assignment. Our presentation today is titled Conduction Graphical Analysis on Heat Transfer. This assignment is presented by our group members, which are Muhammad Raidz Hadziqin, Muhammad Syahmi, Afiq Safwan and Ashraf Takif. In this presentation, we will explain our analysis of heat transfer through thin surface, including design, simulation result, comparison, discussion, and conclusion. Okay, so for this project, our group consists of four members. The first member is Muhammad Raidz Hazikin, followed by Muhammad Syami, Ashraf Takif, and Afiq Safwan. Each member contribute to completing this assignment, especially in designing the thin surface model, preparing the simulation, analyzing the results, and arranging the presentation slides. Okay, so for the introduction, this project focus on the graphical analysis of heat transfer through thin surface. Thin surface are commonly used in engineering application because they help to improve the heat dissipation. The main function of fins is to increase the surface area so heat can be transferred more effectively to the surrounding air. This concept is widely applied in systems such as electronic cooling, heat exchangers, engines, and other machinery that produce heat during operation. In this study, we designed and simulated two different fin surface model. The purpose is to study how the shape, spacing, and arrangement of fins affect the temperature, distribution, and heat flux. From the simulation results, we can compare both designs and determine which design perform better in removing heat. Okay, so the objective of this project are divided into several parts. First, we aim to design and create two different fin surface model based on creativity. Second, we perform heat transfer simulation on both design using SolidWorks or other suitable simulation software. Third, we analyze and compare important the heat transfer characteristic, especially the temperature distribution and heat flux for both design. Next, this project also helps us to improve our problem solving skill by connecting theoretical heat transfer concept with visual simulation results. Lastly, the main objective is to compare both fin surface design and identify which one has better heat transfer performance.
Hello, my name is Muhammad Ra'iz. I want to present about design 1. This slide show our first design, the uniform fin surface, as seen in the top and side view. All fins are of equal length and evenly spaced. The material used is aluminium alloy 6063 T5, which provide good thermal conductivity. The simulation parameters include a fin size of 40 mm by 40 mm, ambient temperature between 28 to 34 degrees Celsius, and a convection coefficient of 5.03 watt meter square Kelvin. The purpose of this design is to analyze how heat spread from the base to the top of the fins, allowing us to evaluate its thermal performance. Next slide is the video. Okay, this slide show our second design, the stepper fin surface from the top and side view. We can see that the fins at the lower section are shorter, creating a stepper geometry. The material is aluminium alloy 6063 T5, the same as design 1. The simulation parameter remain the same, 40 mm by 40 mm fins. Ambient temperature is around 28 to 34 degrees Celsius and a convection coefficient of 5.03 watt meter square Kelvin. This design aims to increase surface area at the base to improve heat dissipation. By comparing this design with this design one, we can analyze how stepper fin affects temperature distribution and overall thermal coefficient. Okay, this is the result for design 1. This image shows the thermal simulation result of design 1. The uniform fin surface, the color gradient represent the temperature distribution across the fins. The base of the heatsink is the hottest area, reaching approximately at 97.5 degrees Celsius, shown in red. As we move upward along the fins, the temperature gradually decreases, with the top of the fins being to coolest at around 76.6 degrees Celsius, shown in blue. The smooth transition from the red to the blue indicate that heat is spreading evenly along the fins. This uniform distribution demonstrates that the fins effectively transfer heat from the base to the surrounding air, providing good thermal performance for this design. Okay, this is a result about design 2. This image show the thermal simulation result of design 2. The stepper fin surface. The bottom face is again the hottest area at approximately at 97.3 Celsius, shown in red, while the top fins are the coolest at around 76.3 Celsius, shown in blue, unlike design 1. This design features stepper fin which increase surface area at the lower section. The heat spread more efficiently in the stepper region, reduction hotspots, and improving cooling at the base. The color gradient indicates effectively heat dissipation, with a slightly faster temperature drop along the fins compared to design 1.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq Safwan Muhammad Iswani. My metric number is B11241024. So we move to the next segment. So here we need to compare between design 1 and design 2. Okay, firstly for design 1, it has smooth linear temperature gradient, effective for general heat dissipation. Hot base cools gradually towards top fins. Next, the design 2. Step fins increase surface area at the base. Heat spreads more efficiently in lower fins, provide slightly more uniform cooling at the bottom. And lastly, enhance overall thermal efficiency. Next, for discussion, first we focus on material. Both heat sinks are made from aluminium alloy C0C3/T5. This type of aluminium is commonly used because it can transfer heat very well. It is also light, doesn't rust easily, and can handle changes in temperature without getting damaged. These properties make it a good choice for heat sinks which need to remove heat quickly and safely. Next, design. The main difference between the two designs is in the number of fins. Design 2 has more fins than design 1. Having more fins help to spread the heat faster because it gives more space for air to move around and carry the heat away. However, if the fins are too close, air might not flow properly. Moreover, the design must need the balanced number of fins with enough space between them to allow air to pass through. Lastly, surface area. The surface area is the total space on the heat sinks where heat can escape. Design 2 has a larger surface area, Because it has more fins, a bigger surface area means more heat can be released in the air. This helps the heat sinks cool down faster and work more efficiently, especially in systems produce a lot of heat.
My name is Muhammad Barizam. My number matrix is B1124100201. For this part, I will discuss for conclusion. So, in conclusion, this graphical analysis has provided a clear understanding of heat transfer through conduction in solid material by using the graph method to represent temperature, dissipation, and heat flux. We were able to visualize how thermal energy moves from a region of higher temperature to a region of lower temperature. Throughout this analysis, we observed the graphical representation made it easier to understand the relationship between temperature gradient and heat transfer rates. Instead of relying only a theoretical equation, the graph allowed us to see the behavior of thermal system more clearly under different boundary conditions. Furthermore, this activity helped strengthen the concept learned in the BLK 2463 course by connecting theoretical knowledge with practical engineering application. It also improved our ability to analyze steady-state conduction problem, evaluate the terminal performance of different materials, and understand the factors that affect heat efficiency. The skills gained from this analysis are important for engineering applications such as thermal system design, energy management, electronic cooling system, and industrial heat transfer process. Understanding this concept enables an engineer to deliver more efficiency and reliable solutions for real-world challenges. Overall, graph analysis is valuable to the and learning and problem-solving ability in thermal engineering. It provides a practical approach to interpreting heat transfer behavior and support the development of effective and energy efficient engineering design. Thank you for your attention.
Okay, so that's all from our group presentation. In conclusion, this project helps us understand how fin surface design can affect heat transfer performance from the simulation and comparison. We can see how different fin arrangement influence cooling efficiency and temperature distribution. We would like to thank Prof. Madya TS Dr. Muhammad Zahir bin Hassan for the guidance and also thank everyone for listening to our presentation. Thank you.